everyone, in this video we are going to talk about orbital diagrams. Some important things to keep in mind as you go through this unit. You're probably going to want to have a periodic table open as a tab, or you're going to want to have a hard copy sitting next to you. It'll be very helpful. I'm also going to try to keep my two screens separate so I can have my PowerPoint over here and I can keep this flowchart over here. This flowchart is going to be really important, and there's a copy in your document that goes along with this video. So as I go through this, you're going to want to fill in the notes at the bottom of the document to help you keep track of everything. Okay, let's get started. Before we get into the heart of everything, let's do a quick review. How do you figure out the number of electrons in a neutral element? Take a minute, think about it. Remember that the atomic number is equal to the number of protons, and protons are positive and electrons are negative. So if you have 12 positive protons, then you're going to have 12 negative electrons. So you want to keep this in mind as you go through this. Your protons are equal to your electrons, which in turn equal the atomic number as long as it's neutral. Okay? As we go through this, there's three main rules that you want to follow. And these will start to make sense as you do the practice at the end too, but you need to have an intro to these rules. The first principle is Aufbau's principle. And what it means is an electron occupies the lowest energy level that it can. So, for example, it's going to be 1s, 2s, 2p, and 3s. It doesn't go in number order. 1, 2, 3. I know the 2's are next to each other here, but it's not always the case. So if we go over here and look at our flow chart, we always want to follow the path of the red arrow. So notice the red arrow starts in the top right-hand corner and goes down to the bottom left. So we start at 1s, we go to the second red arrow, it goes to 2s, then we start the next arrow, it goes to 2p and 3s, and then it goes to 3p and 4s, and then we come back here and it goes 3D, 4P, and 5S. So then we really start to jump all over the place with the different numbers. So you always want to follow the path of the arrows and not go down. Not 1, 2, 3, 4, 5, 6, 7, and then the next one. It goes diagonally like this. So that's an important thing to keep in mind. Okay, the next principle that we're going to look at is Pauli exclusion principle. So what that means is no two electrons in the same orbital. An orbital is a box. I know you think this is crazy, it'll make sense in a little bit, can have the same spin. So an electron is represented by an arrow here, and notice we have one arrow going up and one arrow going down. We cannot have two moving in the same direction. That does not work, okay? So we always have one that spins up and one that spins down. It's kind of like a really bad amusement park ride, okay? The third rule is Hund's rule. So each orbital must get one electron before doubling up. So when you get to P, D, and F, P, D, and F have more than one orbital with them, and when you distribute them, each orbital must have one. So you put one up, one up, one up before you start doubling and going down. It's kind of like passing out cookies or pizza. Everybody gets one cookie or one slice of pizza before you can start to have two, okay? So what are the orbital diagrams? I know it makes no sense, it's kind of confusing right now. But a couple things to keep in mind. An energy level has a different level of energy, different levels of an energy that an electron can live in, and the maximum is 7. So we see 1 through 7 here. It's kind of like 7 different floors of a hotel. We only go up to the 7th floor, okay? An orbital is a specific energy level or a specific area within these energy levels. So it's kind of like a room on that hotel floor. So how many rooms are on the first hotel floor? How many rooms are on the second? And then we keep moving, okay? So an orbital is going to be represented by a box. So if it's an s orbital, it's going to have one box. If it's a p level, then it's going to have 3 orbitals. If it's a d, it's going to have 5. If it's an F, it's going to have 7. Now, one thing to keep in mind is you have 2 electrons per box. So 1 electron would go up and 1 electron would go down. So S can have a total of 2 electrons if there's 2 here. P can have a total of 6. 2, 4, 6. D can have a total of 10 if you put 2 in each box. And F can have a total of 14 if you put 2 in each box. Okay? So anytime you see S, it's going to have 1 orbital. Anytime you see P, it'll have 3. Anytime you see D, it'll have 5. And F will have 7. Okay? So when you go to draw them, you always have 1 electron going up, one going down. Remember that one arrow is equal to one electron, and the total number of arrows must equal the total number of electrons. So if you have 12 protons, you have 12 electrons, so you must have 12 arrows. And you always want to follow that yellow brick road. And this is our yellow brick road, so we're following the arrows. Okay, I'm going to do full screen right now. We're going to do some practice problems together. Make sure you keep this open and have your periodic table nearby. All right, let's do a couple practice problems. So the first practice problem we look up here, some things to keep in mind. We see 1s, 2s, 2p. We followed the orbital diagrams. We followed the path. S we see has one box, so it goes 1s, 2s. Each S always has one box. And then we get to P and it has 3 boxes. Okay, notice that one arrow goes up and the next one goes down. And we filled 1s before moving on to 2s. It's kind of like a video game. You can't go on to the second level until you finish the first. So if we want to figure out the element, we can count the electrons. There's 1, 2, 3. We know, look at the periodic table, we know element number 3 is lithium, and there are 3 electrons or arrows, and lithium's atomic number is 3, so 3 protons is 3 electrons. All right, let's do practice problem number 2. Take a minute to look it over. We did follow the path, 1s, 2s, 2p. You always want to make sure that you follow the path of the orbital diagram, okay? S always has one orbital or one box. S always has one orbital or one box. It doesn't matter if it's 1s or 2s or 3s or even 7s. P has 3 orbitals, so we have 3 boxes right here. Sometimes they are touching and sometimes they're just very close together, okay? So we used our flow chart. Our numbers are in the right order. S has 1, P has 3. Notice that one arrow goes up and one arrow goes down. So one goes up for S, one goes down, one goes up, one goes down. We filled 1s before moving on to 2s. And then once we got to the P, each box got 1 before doubling up. Okay? So now we need to figure out the element. Let's count the number of electrons. 1, 2, 3, 4, 5, 6, 7. Take a minute, look at your periodic table. If there are 7 arrows, that means we have 7 electrons. 7 electrons means 7 protons. And 7 protons, the atomic number is 7, so our element is nitrogen. Did you say nitrogen? You're right. There are 7 electrons or 7 arrows, so lithium is atomic number 7. All right, let's try the next practice problem. All right, let's take a look at this. Once again, let's check our flow chart. We have 1s, 2s, 2p, 3s, 3p. Does that follow the path of the yellow brick road? Yes, it does. Now, S always has one box. P always has 3. You go back to S, and even though it's a 3s, it still only has one box. And you go back to P, and it still has 3. Let's check our arrows. We have 1 going up, 1 going down, 1 going up, 1 going down. With P, we have up, 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 then down, down, down. You go back to S, you have 1 going up, 1 going down. Now we're at 3P. Notice we did not finish 3P all the way, and that's okay. But we did do up, 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 and then we went back to do down. It's okay if you have less than that, but we wouldn't go on to 4S until we fill this in. So let's check our list. We had our flow chart. S always has one box. P always has 3. Notice that one arrow goes up and then one arrow goes down. We filled 1s, 2s, 2p before moving on to the next level. Now, which element is this? Take a minute, check your periodic table. All right, let's count our arrows. Our arrows equal our electrons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What element is number 16 on the periodic table? If you said sulfur, you are right. There are 16 electrons or arrows, and lithium is atomic number 16. All right, let's do one more practice problem. Now, before we do this last practice problem, let's do a quick review. Let's review what an anion is and how is this going to affect the orbital diagram. Think to yourself what an anion is. Remember, an anion is an element that gained or lost electrons. So anions are always gaining, so they will be negatively charged. So if we're gaining electrons, you're going to add arrows to the orbital diagram, okay? And then a cation is going to lose electrons because cations are positively charged. Remember, positive looks like the T, which is a plus sign, and we're going to take electrons away. So we're going to practice drawing an orbital diagram for an ion. Now, I would tell you if it's an ion beforehand, otherwise we're going to assume that they're all neutral, okay? So if we want to draw an orbital diagram for Na plus 1, we have some things we want to keep in mind. The first is we want to draw the regular diagram for sodium. So you're going to follow the yellow brick road. Remember, S always has 1 orbital, P always has 3. So it should look something like this. You have 1s, 2s, 2p, 3s, because we have 2, 4, 6, 8, 10, 11 electrons. Sodium has 11 electrons, so we know we have to draw 11, okay? We want to ask ourselves, are we drawing an anion or a cation? So it's a plus 1, so since it's a positive, we know it's going to be a cation. Cations are going to lose electrons, so we always take one away. Remember, it's always the opposite up here. If it's positive here, we're actually going to lose one down here. Okay, so we're going to take one away. And now we can draw the cation for Na plus 1. So we still followed the orbital diagrams in the same order, but this time we took one away, so 3s is no longer there. So we end at 2p, and we write it Na plus 1. Make sure you write the Na plus 1, otherwise it could be taken as neon, 2, 4, 6, 8, 10. So you must have the Na plus 1, okay? So let's do a quick review. How many electrons can fit in one orbital? One orbital is a box, and each box can hold 2 electrons. How many electrons can S hold? S has 1 box, so that's 2 electrons. D has 5 boxes, and if there are 5 boxes, that means 2, 4, 6, 8, 10. Okay? Now, I want you to take some time and do the practice problems at the bottom of the paper. If you have any questions, let me know. And if you need anything, you know how to get into contact with me. Thank you.